Right. Good morning, everybody, and welcome to day 5 of the Nottingham Festival of Science and Curiosity, and indeed our 5th session of Ask the Scientist, your opportunity to find out about how people working in science, technology, engineering and maths have arrived at the roles, the jobs, the research that they are doing in day to day. It's an especially warm welcome if you're joining us from schools or from home, and to schools in Gedling, in the Gedling Borough Council area, who are joining us as part of their Build Your Future Week, which is also coincides with Apprenticeship Week. This morning, we're coming to you from a virtual studio and beaming out on YouTube. And I should also mention that we've got a wonderful panel this morning. I should have perhaps described this as Ask an Engineer, because our panelists this morning all work in the field of engineering. I always love talking to engineers because they are some of the most creative and innovative people that you can find working in STEM. I think they are, I think a lot of the problems, the answers to the problems of our future lie in the imaginations of engineers. Anyway, I'm going to quickly briefly go around the panel and then tell you a little bit about how this session works. So on screen at the moment, you will see Isabella. Wave, Isabella. Izzy is going to be our tech support this morning, so will disappear from our screen shortly, but is there to give us technical support. Jacob, can I invite you to say hello and welcome?
Hi, everyone.
So, Jacob, you work at the University of Nottingham?
Yes, second year PhD student at Nottingham.
Great. Well, we'll find out a little bit more from you what that all means in just a while. And a good morning to you, Oliver.
Hello, I'm Oliver. I'm also a second year PhD student at Nottingham.
Nice to meet you, Oliver. Annalisa, say good morning.
Hello, good morning to everyone. I'm a third year PhD student at the University of Nottingham.
A third year student, thank you. And Chris, good morning.
Morning. I'm also a second year PhD student at Nottingham.
Great. Well, you're all very welcome, as indeed our viewers, our audience on YouTube. Now, you're watching us on YouTube, and you are welcome to place your questions in the comments panel of YouTube. Just a little word about our expectations of you as members of the audience. We have a code of conduct for the Festival of Science and Curiosity, which encourages or asks people to use inclusive language and to be respectful of each other in your comments and your questions. So the way this will work is that I will ask our panelists, our engineers, to give us a short presentation, a short talk about their careers, how they've arrived at the position that they're in at the moment. We'll go round each of the 4 panelists, and then we'll have time at the end for your questions and your observations. So without further ado, thanks for being here. We look forward to your questions on the YouTube comments. And now I'd like to hand over to Jacob to make his presentation.
Thanks, Rick. Hi, everyone. I'm Jacob. And as previously said, I'm in my second year of my PhD at the University of Nottingham. I think I should start off by saying I was probably first interested in STEM probably around your guys' age when I was sitting my GCSEs. I decided to take triple science purely because I enjoyed them, found them interesting, and I thought in the long term they'll be useful. And then I chose the three sciences: chemistry, physics, biology, and also maths for A level. Even though Rick said we're all engineers, I actually studied chemistry as my first degree at university. So that was a 4-year master's course. Even though I enjoyed it, I didn't really know what I wanted to do. Actually, still coming out of university with a chemistry degree, there was lots of options, and there's a minefield of jobs out there. But I actually went away from science briefly, and I went into finance. I worked for 2 years. You do a lot of maths in a chemistry degree, and that's what they were after. So I did that for 2 years. However, I did not enjoy it. And that resulted in me in taking up the position that I'm currently in at Nottingham. So I'm actually under the engineering faculty. However, my project that I'm doing is quite chemistry focused. So it's called something called materials engineering, which hopefully one day, if you do find out, you'll find out it's basically just chemistry. But the project I'm looking at is solid state hydrogen storage. So hopefully you're all aware that climate change is a big problem we're all facing at the moment, and you might have started to see some electric cars out on the roads. They don't make any noise, and you don't see any fumes coming out of the tailpipe. This is because when you use electricity to power a car, it doesn't give off any of these harmful CO2 emissions which contribute to climate change. There's a few issues with these electric vehicles. The energy stored on these vehicles is in the form of a battery, and batteries can be really heavy. They can be slow to recharge once you've used it up, and they also degrade quite quickly, meaning they're only in use for how many years before you have to change them. So I'm looking at hydrogen storage. Hydrogen has been really kicking off the past sort of 10 years as a clean energy store. So the concept is you can store hydrogen as a gas on a car, feed this hydrogen into a machine called a fuel cell, which will also produce electricity. So just like a battery electric vehicle, but the energy storage is in the form of hydrogen rather than a battery. And this is good for a number of things. To recharge, to refuel your car, it's a lot quicker. You also get a lot more mileage. So say you go to a petrol station, you fill up your car, it gives you 500 miles. That's a similar thing with hydrogen, whereas a battery is a lot less. And that's all well and good. But at the moment, the way the hydrogen is being contained in the car is in the form of a gas. And this is at very, very high pressures, which is dangerous because the vessels that keeps the hydrogen in are obviously strong and good, but they can rupture and lead to hydrogen release. And hydrogen is a flammable gas. So if it reacts with the air or the water in the air, it can explode. So it may sound a bit dangerous, but there are ways around it. And what I'm looking at is instead of storing it on the car as a gas, it would be storing it as a solid. And the beauty of this is instead of storing it at really, really high pressures, you only have to store it at small pressures. So it's a lot safer. And also you have to heat up the hydrogen, heat up the material to get the hydrogen off into the machine to produce the electricity. And this also reduces the temperature by storing it as a solid. It can not only be used for cars, but it can also be used for heating your home. So if you think about the boiler you will have at home, that burns natural gas, which is great because it gives you heat, but it can also lead to harmful emissions, contributing to climate change again. You can also burn hydrogen, heat up your home, but the only thing being released is water, which is great. So yeah, that's me. Currently in my second year of my PhD. So the rest of this year and another 2 years to go, mainly on a day-to-day basis, would be sort of going into the lab, looking at certain materials and testing why they're bad or not, trying to figure out why. And once we figured out why, if it's bad, I could try and make a new material which is better, so on and so forth, till we can hopefully find something that will work perfectly. So that's me. Thanks, guys.
Wow, thank you, Jacob. I'm glad that we've started off with some of the really big questions like climate change and so on, and we're getting some comments already that that's a pretty cool piece of research that you're doing there. And we'll find out a little bit more about how you arrived in that particular department, I think perhaps through some questions later on. Oliver, I wonder if we could now turn to you to find out a little bit about your journey.
Sure. So there's going to be a lot of overlap with me and Jacob because I also work with hydrogen storage. So I've always been interested in science, particularly maths. That's always been what I've been interested in. And I've just, every stage of education, I've decided to go into maths. So I did a maths A level, did a maths degree, did a maths masters. So you might be wondering why I'm into engineering. It seems a bit strange. Essentially, I just wanted to do something a bit more practical. Thing with maths is you often find that although it's very interesting to you, not many other people understand what you're talking about. So I wanted to see if I could apply the maths to something more applied. And that ended up being hydrogen storage. So just to give you a little bit more background from like a different perspective on hydrogen storage. Obviously, as Jacob said, climate change is a big issue. And people are often wondering why we don't just swap to wind turbines, solar cells, that kind of thing, because that seems like the obvious thing to do. And the problem with that, as silly as it might sound, is the wind does stop blowing every now and again and the sun does go down. And in that time, you want to be able to have a consistent amount of energy going into the system, because if the energy is fluctuating all the time, it causes issues. So the solution to that really is to store the energy. So that while you've got too much energy, you store it, and then when you've got too little, you send in that extra energy to sort of balance it out. Now, you could use batteries for that, but it turns out batteries aren't as good as we're led to believe. I think, as Jacob mentioned at one point, batteries, they end up being quite heavy. So if you take something small, much smaller than the energy grid, take your fridge, if you want to power that for a day without plugging it into the socket, you just want to have a battery, you're going to need 120 kilograms of batteries to power that fridge for a day. So that's a problem. That gets quite expensive. In some cases, like in cars, you can't deal with that kind of weight. So hydrogen is the other solution. Hydrogen is the lightest element. So it's quite an obvious place to look for a light energy store. And it is about 200 times lighter than batteries when it's storing energy. But the problem with that is it takes up a lot of space. So you imagine hydrogen's a gas, it's moving around really quickly, and it ends up sort of bulging outwards because it's knocking into itself. So one of the ways to store that hydrogen in a smaller space is to sort of absorb it into another material. So one of the most common ones is a metal sponge, they call it. So in the same way that rice will sponge up water to make it take up less space, you can use metal to sponge up hydrogen. The trouble with that is we don't fully understand the process through which hydrogen goes into the metal. So it's taking a lot longer than it should do. It's not quite happening at as fast a rate as we would like, and we don't really know why. Finding out why through lab experiments alone is quite difficult, because we want to see what's happening on the atomic scale, and you can't really see something that small. So my approach is to, instead of being in the lab, I'm simulating it. So I'm using all of the maths knowledge that I gained from my degree to sort of simulate the situation on a computer. Now, there's two main ways you can simulate atoms on a computer. You can use sort of simple mathematical expressions like you'd see in secondary school. And that's not very accurate, but it's quite fast. So if you want a speedy simulation, that's the way to go. But unfortunately, it's not accurate enough for this particular situation. The other way is called density functional theorem, which is a very complicated quantum mechanical idea, but it takes a very, very long time. So you get the accuracy, but you're going to be waiting about a year for your simulation to run. So that's not very helpful. So what I'm doing is I'm using machine learning, which is sort of a process by which you can teach a computer to solve a problem for you. I'm using machine learning to sort of teach a computer to mimic DFT, the density functional theorem. So it's getting those accurate results, but it's getting them much, much faster. So I ran a simulation the other day that should have taken about a year if we were using the accurate approach, but instead of machine learning, it took about 6 hours. So that's what my research is around.
Great, thanks, Oliver. We've already got some questions here about hydrogen. We know that it's a very volatile, or could be a very volatile gas because it is flammable. We'll come back to some of these questions, but reminder to our audience: keep posting your questions in the chat function on YouTube. Now, I'm going to introduce. We've got another Chris joining us. Chris, good morning. Nice to see you.
Hello everyone.
You're very welcome. We're just going around each member of our panel this morning to find out more about their journey into the research that they're conducting at the moment. So we've heard from Jacob and we've heard from Oliver, particularly around hydrogen as a source of clean energy for cars and for electricity and all our other uses. But now I'm going to hand over to Annalisa. Annalisa, would you like to tell us a little bit about your journey to where you are, please?
Yeah, of course. Thanks, Rick. So I come from Italy. I've always been interested in science. In Italy, it works that you can choose from the very beginning which high school you want to carry out. So I chose a scientific high school. So I started very early to develop my skills in math and physics. Then I wasn't sure between medicine and engineering, but eventually I picked up energetic and nuclear engineering. So I did my bachelor and also my master in Italy. Then during my thesis of the master, I collaborated with the University of Nottingham. And they offered me firstly to be 6 months here as a researcher, and then they offered me my PhD, but it is in mechanical engineering. So it's, let's say, similar to energetic engineering, but in energy engineering, you would look more at the process of heat transfer and the improving the efficiency of the plants. Whereas in mechanical engineering, you look more at the components and to tiny little details. My PhD is on an innovative prototype that we would like to use in the hybrid hydraulic vehicles. So always regarding the climate change, we know that we need to lower the emissions, especially of the transportation industry. I'm sure you already know about the electric hybrid vehicles. They're mostly used in light passenger cars. So in your normal car, you can have an alternative system to recover the energy from the brakes. However, there are some limits because the infrastructure yet are not ready for accommodating all these kind of vehicles. Especially regarding heavy-duty vehicles. So if we think about commercial vehicles, if you think about your Amazon courier that brings you your package, it's really hard to install an electric hybrid system on that kind of vehicle. And furthermore, for example, on the very heavy transportation, like international transportation, you cannot have this kind of system for because of the power requirement. So my research is looking to offer an alternative to these electric vehicles, and we are working on hybrid systems. So the principle is the same. You want to recover energy from the braking, but you can do that using a hydraulic system. So you can use a system of accumulators, of a high pressurized fluid, of a pump, and in this way you can retrofit in a simpler way a commercial vehicle. In my research, I'm looking particularly to couple this kind of technology with another technology for improving efficiencies generally in cars, which are assisted turbocharger. So a turbocharger, very simply speaking, it's a device that allows you to recover some energy from the exhaust gas. So we take something that usually is a waste, which are exhaust gases. You put this into a turbine. The thermal energy of the exhaust gas can activate the turbine, which is mounted on the same shaft of a compressor. So the compressor can compress more air into the engine, and this improves the efficiency. Now, in the turbocharger, there is also an issue which is called turbo lag. This means that in order to reach the exact and proper speed to give the proper pressure to the engine, it takes from 3 to 5 seconds. It depends on the model. And of course, there is this kind of lag in the power output. We are trying to solve this lag introducing an assisting device. So it's still a prototype. We cannot talk a lot about that, but we are trying to reach the level of technology that can allow us to test this not only in the laboratory but also in commercial vehicles. So just to summarize, my research is to try to couple in the best possible way the hybrid hydraulic technology with the hydraulic assisted turbocharger. I'm really interested in this research, and I really like the aspect of the of always investigating what's new and what I can do for everyone else. Thank you.
Thanks, Annalise. Yeah, I think it's always fascinating for me that actually when you're in a vehicle and it brakes, that actually that's using energy in order to slow up the vehicle. And actually that energy could be if you could capture it, you could use it perhaps to power the vehicle going forward. So that's always been a matter of some fascination for me. But yes, anything that improves the efficiency and of vehicles, I think is going to be really important for the future. Okay, so we've got two Chris's next. We'll come to you, Chris Ryder, first, if we may, to find out a little bit more about your journey and research.
Yep, thank you. So I think similar to the others, I was always more into science at school. I think I was probably better at it than I was at art, for example. I think I probably found it more interesting. That's maybe why. So for my A-levels, I ended up doing physics, chemistry and maths. I didn't really know what I wanted to do career-wise, even when I finished school. So looking for uni courses, I was just looking for something to try and carry on doing science. And so I did natural sciences, where I was able to basically just carry on my A-levels. And then even after university, I did a master's and I still wasn't entirely sure what I wanted to do. And I took a year out to sort of assess look around and see what was there. And I found this. I'm also on the sustainable hydrogen program, the same as Jacob and Ollie. And it was, I always thought PhDs was very academic and it wasn't exactly what I wanted to do at the time. But this hydrogen one that we're on is called a CDT, which is a Centre for Doctoral Training. And it's where you can do a PhD with sort of a focus on doing industrial research. So you can be sort of ready for the real world by the time we're finished is the aim. And so, yeah, I didn't really know that that was a thing until I stumbled across it, and I'm quite thankful that I have. So I think it's quite useful to know that you can do a PhD and stay in academia, but there's also ways you can branch out even if you do a PhD. But yeah, as I said, I'm in the sustainable hydrogen program, so I won't cover the hydrogen again because I think Ollie and Jacob have done that okay. But my project is looking at hydrogen storage as well, but it's more focused on this technique that's used to analyze different materials that can be used for this hydrogen storage. It's called XPS, and it uses X-rays to fire them at the surface of a metal, for example, when it's reacting with hydrogen, and you can see sort of what's going on with the X-rays. The problem that we have is that this requires very low pressures, so it's called ultra-high vacuum, whereas the reactions that are occurring with the hydrogen are at more higher pressures, so just above atmospheric pressure. So what we need to do is be able to bridge this gap between extremely high pressure and extremely low pressure. And there's a few techniques that have been tried over the years, but my sort of project is to try and design a device that's able to do this. I'm only in my second year, so I'm not all the way through yet, but it's going quite well, I think. And the aim would be to be able to use this X-ray technique to look at hydrogen storage materials. So, for example, Jacob could maybe use it with the materials that he's creating. And maybe I would as well if it's successful. But yeah, I think that's pretty much everything.
Great, thanks, Chris. And of course, one of the things that I always like to hear about research is that you don't get it right first time, and of course, part of the ways in which new discoveries are made is that it's through trial and error. You try something. Maybe it works, maybe it doesn't. If it doesn't work, you then move on and try a different version of it, try something different. And that, I always think, is a very creative way of thinking. So whilst you said you didn't think of yourself as being particularly strong at art subjects, I can just bet that you're using a lot of creative thinking in your research now. Brilliant. Okay, well, now finally, but not least, Chris, we come to you to find out a little bit more about your journey and your research.
Yeah, sure. Thanks, Rick. I come from Cyprus. I came in England in 2015, and I studied mechanical engineering at Nottingham. I also took a year out in industry during my fourth year. And I'm now doing my PhD. I'm a first year PhD student under the combustion engines group. My research is focused on improving the efficiency of passenger cars via a novel combustion system. So we call it turbulent jet ignition. It basically replaces the spark plug in a combustion engine. Gasoline engines we're talking about. So you replace a spark plug with a pre-chamber, and combustion is initiated in that chamber. And instead of one ignition point that you had before, now you have multiple jets spouting out of the pre-chamber. And this provides many benefits regarding efficiency and harmful emissions. So we want to look at many different things in terms of fueling strategies, injection timing, possibly other types of fuel for the future zero carbon ambitions of the UK. And we also want to combine the system possibly with electrified systems, so for hybrid vehicles. One good idea that we are having at the moment is having a range extender engine on an electric vehicle, so you can have a smaller battery. So the batteries basically have a big environmental impact, as you may know. So if you have a small efficient engine to provide electricity on board, then you can have an extended range instead of carrying around a big, a huge 100 kilowatt hour battery, for example. So yes, I guess similar to the others, I guess we're all good at STEM subjects, and I see engineering as one particular field which is very, very applied and very diverse also. There are many things that you can do with an engineering degree. So as far as going into a PhD, I guess I've always enjoyed learning, and I wanted to carry on doing that instead of going into the job market, I suppose.
Great, thank you, Chris. Well, I wouldn't say you were avoiding the job market. I think you're contributing to lots of more jobs for us in the new, in the new vehicle industry. Well, thanks everybody. Just a reminder to our viewers that you can post your questions in the chat, in the comments section over on YouTube. We have got one particular question from Martel, and it's about the, if you like, the explosiveness of hydrogen. Jacob, could you just pick up that question for us, please, and explain, how can we make hydrogen a safe fuel, and how explosive is it?
Yeah, so it can be considered quite dangerous. I wouldn't recommend trying to make explosives from it. I think you will be successful, but we want to use it for the good. And the problem with hydrogen is if it gets mixed in with the air we breathe, it can produce it can be flammable and give off gases. Give off flames. However, it's quite a high concentration of hydrogen in the air, so I wouldn't be too worried about it. And also, with current hydrogen cars, there are a lot of safety measures in place. So there's sort of outlets where they disperse the hydrogen into the atmosphere. There's so much air around, it can't form that flammable mixture. There's not enough hydrogen in the air. So yes, it can be explosive, but there's a lot of research and a lot of good research into making them not explosive. And there are current cars, I don't know if you've heard of Toyota and Hyundai, they all have hydrogen cars which you can buy, so they are safe. Otherwise they wouldn't be selling them.
Yeah. No, thank you, Jacob. I'm sure that's right. Okay, so panel, I'm going to ask you in turn what it was that really first inspired you as a child. What was the spark or the moment of, if you like, curiosity that made you think, I want to know more about this. I think I might want to explore the world of engineering or science. I think what I'll do is I'll go round in reverse order. So Chris A, what was the moment when you were a child that kind of first inspired you to think of STEM?
If I would to pick one, I would say it was probably Formula One. So during the early 2000s, it was very, very popular, especially internationally. And I don't know. I suppose when you were watching it on the television, something there was a know about it. Certain, I don't know, excitement that was caused by probably the sound, the drivers, and the pit crews. So yeah, I guess if I could pick one, like the earliest experience I can think of, is probably that.
Formula One, yes. So of course there's quite a lot of talk about whether there'll be an electric version of Formula One. We already have Formula, don't we? E racing cars. So that's going to be an exciting point. Thank you, Chris. Other Chris, you wanted to keep your options open, I think, for quite a long time. But what was it as a child that first sparked your interest in perhaps scientific subjects?
I can't think of a single moment, but I think my parents were both quite scientific. They were both doctors, so I think that was a sort of I don't know the way I was brought up really, but and also my grandpa was he used to work at nuclear power plants and also building the Channel Tunnel, so he was all engineering based. And yeah, I think maybe it was just the sort of, it was always in my mind that, and yeah, I think I was just better at it than other things. But yeah,
Brilliant.
yeah.
Well, I think it sounds like engineering or medicine or science was in your family. I love the idea that your granddad was involved in the Channel Tunnel. Great. Annalisa, what was it for you that kind of sparked your interest in Italy?
Okay, so I've always liked actually going to school. I know it's unpopular, but I've always liked to go to school. I always thought it was a great opportunity to learn every day. And I really enjoyed learning math with my primary school teacher. She always challenged us, but in a very productive and positive way. So then I discovered also physics in high school. So for me, it was more about education. So I've always liked the fact that we can always learn. But because of my personality, I'm a really practical person. So I wanted to do something practical. I couldn't just live off numbers in the air, let's say. So initially, I wanted to do medicine to help people. However, I discovered that I'm not really into medicine because I'm really afraid of blood and injection. So I thought about another way to apply math, physics, and to enjoy the scientific world. So I thought about engineering. And actually, I tried to start medicine, but in Italy, it's really hard to get into a university. You don't just need to pay; you need to pass multiple tests. And for medicine, there are always a lot of people. So I did pass chemistry and technological science, but I didn't pass medicine. So I chose engineering, and I think it was the good choice for me. So yeah, as for Chris, I didn't have an exact moment. It was more of a process, and I think that honestly, it doesn't need to be attributed to just one moment. It needs to be something that grows in you day by day, discover little things.
Yeah, great. Thank you, Annalisa. But clearly you had a love of learning as a child, and also you mentioned that you were interested in practical subjects and being practical. Oliver, what was the spark for you?
Like Chris, I'm not sure there was a particular moment. I think it's kind of a positive feedback loop with me. From a very early age, I was good with numbers. And then when you're the best in class at numbers, you want to do numbers all the time. So you do numbers in your spare time, and suddenly you're getting better and better and better at it. And every stage of the process in education, I think maths was always the thing with me that I knew more than everyone else. So I just kept adding on to my knowledge, and it got to the point where now I'm here. There were a lot of sort of inspiring things about maths along the way. I think it sounds silly, but a lot of YouTube channels that are up nowadays. You got Minute Physics, Number File, things like that. I think they really held my interest when school wasn't quite teaching me to a level that I found interesting anymore. It was nice to hear about all these other topics that are out there. You know, things about fractals. So fractals are sort of self-similar shapes. So you zoom in there's always something interesting. The more you zoom in, they're quite interesting to look at. Things like quantum mechanics, things like set theory, just learning about topics that I wasn't technically supposed to know about yet. I think that really held my interest more than anything else. And then obviously when you go to university and you know these things already, it makes life a lot easier because you've already had the introductions. You have a rough idea of what's going on.
Yeah, great. Thanks, Oliver. Yes. So you were looking across the internet and other web platforms for inspiring kind of ideas around maths. That's fantastic. Jacob, What was there a spark for you?
So, yeah, similar to Chris and Oliver, I guess I did really enjoy sort of the sciences at school, and they were my best subjects. So naturally, I did go on to pursue them further. Again, when I got to A levels, I did them all the sciences, and I was really unsure. I enjoyed them all, but to be honest, I had a really, really good chemistry teacher, and I think he played quite a big role in me going into chemistry. Yeah, he taught it very well and made it simple for me to understand. And I don't know, I liked how clever he was, and I wanted to try and get to his level. So I know he did a PhD. So yeah, I think that was that. And also, since I've gotten older, probably trying to make a difference, because I've done work in a non-science area, and you're sort of doing the same thing every day, and it's not really different, and you're not really making a difference. You're just doing your job. Whereas I think you're always learning and trying to make a difference. So
yeah, that's a great note, Jacob. Thank you. Yeah, I think a lot of students are concerned that they may end up doing the same thing day in, day out, but you are all, I think, clearly tackling problems from different angles and different approaches. Now, Imari has asked a couple of questions. One is, did any of you do DT, Design and Technology, at either GCSE or A level? Could you put your hands up if you did? Oliver, yeah, and Jacob, nearly, yes.
Yeah, just a GCSE I did.
Yeah, and Imari also wants to know what's the prospects of making a rocket car? Let me go to Chris Ryder for that one.
I'm not sure really. I think I guess it could be done. I know that hydrogen is used in rockets, so maybe if you put that on the back of a car, I don't know, if you're trying to break the land speed record or something, maybe that could be a way of doing it using hydrogen. Who knows?
Yeah. Does anybody know what's the fuel that they're using for the Blue Streak attempt at the world record, land speed record? Is that conventional fuel? Oliver, are you?
I haven't got a clue. I'd imagine it's rocket fuel, but that would be my guess.
Fuel. Yeah. So Imari, if you're interested, look up the Blue Streak on internet and see what they're using there to make a rocket car. They're aiming, I think, for 1,000 miles an hour. Certainly, they're attempting to break the sound barrier. Okay, we've just got a couple of minutes left, and I think that one of the things that I'm always fascinated about is how international subjects are. But just briefly going around, what do you see as being the next big breakthrough for your particular area of research? The next big breakthrough. Chris, A?
When it comes to vehicles in general, I would say a breakthrough in battery technology. So making batteries with bigger capacity that do not take as much volume or weigh as much.
Brilliant. Okay, thanks, Chris. I'm going to hurry you because we've only got a minute left. But
sure.
Chris R., what's going to be the next big thing in your research?
I think maybe hydrogen being used more widely in all of the economy. So yeah, I think the wider adoption of hydrogen to replace fossil fuels. Brilliant.
Thank you, Chris. Annalisa?
I think the next breakthrough will be through materials, so developing new lighter materials and new materials for heat transfer efficiencies probably.
Yeah, I think you're right. I think new materials are going to play a huge part in our future. Oliver?
I'd say getting to the point where we actually understand the process through which hydrogen goes into the metal and what's slowing it down will be the next big thing for me.
Okay, well, good luck with that. And Jacob, to wrap us up, what's going to be the next breakthrough?
Yeah, I definitely agree with Chris. You'll see hydrogen in transport. Really specifically, you'll start to see hydrogen trucks and big lorry taking long distance. That's the first thing.
Well, thanks, everybody. Thanks, Jacob, Oliver, Annalisa, and the two Chris's for joining us this morning. Thank you for our audience who posted our questions on YouTube. Just a reminder that, or just a note that tomorrow afternoon at 2:30, we've got an extra special event on the Festival of Science and Curiosity, which might appeal to anybody who might be interested in sound engineering. We've got the science of beatboxing and sound apps happening tomorrow at 2:30. So if you look on the festival website, that's notsfosac.co.uk, you'll find information about a special extra workshop happening tomorrow afternoon. But for now, thank you, everyone. Thank you to our audience, and a special thank you to our panel. Good luck in all of your careers. Good luck in all of your research. And we look forward to seeing you sometime in the future. So we'll end it there. Thanks, everyone. Bye for now.
Thank you.
Thank
Cheers.
you.
Thank you.
Yes, bye.